In this video, we will try to understand the tutorial on NumPy. So there are so many exciting things to learn in this NumPy tutorial. So let's start. So we will start with first part, and that is array. So array is a basically central data structure of NumPy library, and basically array is used to structure the data in such a way that the finding of a data and the location of a data is very easy. Basically, it works on two important things: how to locate the data and how to interpret the data. So array is a grid of elements that express in a various way. So what are the different various way? The first part is 1D array. So to use NumPy, we have to import NumPy. And I'm using NumPy as NP. So whenever I write NP, that means I'm actually calling the library NumPy. Okay. So let's run this. I'm working on a Google Colab. I hope you also are working in a Google Colab. If not, it is a Jupyter notebook format. Great. So let's go. So 1D array, you can see there's only one axis. Okay, there's one axis, 1, 2, 3, 4, 5. Now we can store this 2, 3, 4, 5 list, tuple, set, and dictionary also. But the thing is, why to go for array? It is very easy to locate the elements in array. That's why the array is always choose over list, set, tuple, and dictionary. That's why it is choose over always list, set, dictionary, and tuple. Okay, so there is a 1D array. You can see there is only 0 axis. Now, how to create this array inside the NumPy? So, creation of a 1D array. Now, what is the meaning of that? So, first I am writing x equal to np a range 2 comma 6 and reshape to 4. So, when you write a range operation, it's not a range, it is a range operation. So, whenever you write a range, what will happen? You just need to put here, suppose a comma n. So there will be start value, there will be end value. What will happen with a range operation? So it is going to create the value from a to n minus 1. Okay, let's try to understand what is a range operation from 2 to 6. Okay, so it is going to create the value from 2, 3, 4, 5 because n minus 1. Great. So how many elements are there? So there are elements. How many elements are there? There are 4 elements. So I'm reshaping it to 4. You can see I'm reshaping it to 4. If there's a 5 element, I have to reshape it to 5. Okay, and let's print it. Okay, so though your 1D array is ready, it look like this: 2, 3, 4, 5 in simple bracket. Great. So let's try to see how 2D array will look like. So you can able to compare 1D array and 2D array. So in 2D array, we have two important things, that is axis 0 and axis 1. Okay. So axis 0 and axis 1, the elements are placed in a way that it look like a matrix, but it is not matrix. It is array. Okay. Don't get confused by matrix and the array. Okay. It look like a matrix where you have the x elements, you have y elements. Okay, you have row elements, you have column elements, but it is axis 0 and axis 1 for 2D array. So let's create this. How to create this? So I'm taking again a range operation. So this is a range from what value to what value? It is from 2 to 10. So it means it is going to create 2, 3, 4, 5, 6, 7, 8, 9. Great. So it is actually creating how many elements? It is creating almost 8 elements. Okay. 2 to 9 is 8 elements. Okay. So this 8 elements, I'm going to reshape it to, I'm going to reshape it to 8 only. So the multiplication should be 8. So reshape it to number of elements. So if you multiply 2 with 4, it is going to be 8. Okay, so reshape, you have to make sure that it should be number of elements. So now number of elements is 8, so multiplication should be 2 into 4. Okay. You can do 8 into 1 also, 1 into 8 also, 4 into 2 also. Let's see what will happen when you do this way. So I'm going to run that. Okay, you can see there's a main bracket which is coming up, and inside that there's small two brackets are there. Okay, so when I write this way, I have my own terminology to understand this. Always this will help you. So when you write two, that is two main brackets, two main brackets, and inside that brackets, four means there are four elements. Okay, so two is two main brackets. You can see bracket number one. Which are the two main brackets? That one bracket is 2, 3, 4, 5. And the second bracket which I'm talking about is bracket number 2, and that is 6, 7, 8, 9. Great. And what are the elements? What are the elements? So in each bracket there are four elements, you can see. I hope this is very much clear to you. Now suppose if you write 4, 2, so what will happen to the answer? So multiplication now is 4, 2. So what is going to be happen? There will be now four main brackets, and inside that there will be two elements. Okay, so now there will be four main brackets and two elements. Let's see how the output look like. Okay, one bracket number 1, bracket number 2, bracket number 3, and bracket number 4. Great. So now there are four brackets, and inside that four brackets there are two elements. If somebody wants to write 1 into 8, what will happen? Okay, so 1, 8. When you write 1, 8, there will be one main bracket and 8 elements inside that. Oh, you will see it look like a 1D array only. But in 1D array, we have only one bracket. In 2D array, you can see there are two brackets. So don't get confused with that. Okay, even if it look like a 1D array, but it's not 1D array. If somebody wants to write that into 8 into 1, that is also completely fine. Okay, so now there will be 8 main brackets, and each bracket will be having one elements. Now, I hope this concept is very much crystal clear to you. So let's go for a 3D array. So now there will be three axes, axis 0, axis 1, and axis 2. Great. So now these axes are basically the way the elements are being kept. It looks like a cube. Okay, let's try to understand that how to create a 3D array. One thing I will want to say, it looks like a cube, but you can have number of element on a x-axis, y-axis, and 0 axis, 1 axis, and 2 axis as per your wish. It's not compulsory that it should be on a square format. Okay, let's try to see how it actually look like. So when you write a range operation from a range operation n, so that is going to be create the value from 0 to n minus 1. Okay, so now we have 24. That means it is going to create the value from 0 to 23. So how many elements are there? How many elements are there? 24. Okay, so the multiplication should be 24 for sure. Okay, like here we have a reshape, that is 4 into 2. Similarly, here also the reshape should be multiplication of the number of elements, and the number of elements is 24. So the multiplication which we are taking is 4 into 3 into 2. So this is basically going to be 24. So now let's see how it actually look like. Then I'll tell you the interpretation of 4 into 3 into 2. So you can see there are 4 mini brackets. Okay, so I want you to see this bracket. Okay, so this look more clear over here. So this is bracket number 1, this is bracket number 2, this is bracket number 3, this is bracket number 4. So I have my own terminology to understand that. So I would say this is the main brackets. Okay, so this is the main brackets, and these are the number in term of how much? 4. So we have 4 main brackets. I'll just highlight one more time. This is 4 more brackets, main brackets. Okay. And now we have the next one, and that is mini brackets. So inside one main bracket, there will be mini brackets. So how many mini brackets are there? 3. You can check out. Okay, this is a 3 mini brackets. Inside each mini brackets, how many elements are there? So like we have the elements over here 2. Here we have elements as 2 itself. Okay, so you can see in each mini bracket there will be 2 elements. Great. So I hope this is clear to you. So let's change it. Suppose if somebody write it 6, 2 and 2. So there will be now 6 main brackets. Inside that 2 mini brackets and 2 elements in each. Very crystal clear. Great. Let's take this next one. Suppose if somebody was to write it 2 main brackets, there will be 3 mini brackets, and each should have the 6 element. No, this multiple, it should have the 4 elements. The multiplication should be 24. So there are the 2 main brackets, main bracket 1, main bracket 2. Inside that, the 3 mini bracket, okay, 1, 2, and 3. 1, 2, and 3. And inside that, each mini bracket will be having 4 elements. So I hope 3D array is very much clear to you. Okay. So this is a one way of creating 1D, 2D, and 3D array. There's some other way also, like this is a fixed number of elements. Serially we are taking 0 to 23, 1 to 9, or 1 to 10. But suppose somebody wants to create an array with a different values. So that is also possible. Okay, you can create a 0D array also. Just write only one value, and that will be your 0D array. Actually, it does not make any sense of creating 0D array, but you can still do that. Okay, so let's go and try to understand the next part, and that is 1D array. Okay, so 1D array only gives single bracket and write down array as a keyword, and your 1D array is ready. Great. Okay, so now what we can do, we can have the 2D array. So you can see there is one main bracket. Inside that there's main bracket 1, main bracket 2, and inside that there are 2 elements. So you can create a 2D array like this. Great. Okay, and now I want you to see this one. So I'm just highlighting that first. Okay, this is a main bracket. This is a main bracket. Inside that there are 2 mini brackets, and inside that there is a 3 elements. So this way 3D array can be created. Okay, sound interesting? Great. So let's go to the next one. Suppose you have 1D array. So how to access the elements of 1D array? How to access that? How to access the elements of 1D array? So let's try to understand this. So suppose 1D array is created, and I want to check the position of each one of them. So the 15 is basically at the location 0. Great. The 20 is at the location 1. Okay. 35 is at the location 3, and so on. So now this is a very crystal clear concept. Okay. So when you write 0, B of 0, it is going to tell me that 15. B of 3, it is going to tell me 67. Similarly, we have a negative indexing is also possible. Like the last 50 is considered to be as -1. The 89 is considered to be as -2 location. Okay. Next, we have the 67 is considered to be as -3, and so on. So when you write -1, it is going to take the value as 50. If somebody write -6, you just kind of count that -1, -2, -3, -4, -5, and -6. So 15 will going to come for sure. Okay, great. So now this is very clear. Now if somebody write this way, let me write out here itself, hash Okay, 1 colon n. So this is going to take the value from, sorry, a colon n, a to n minus 1. Okay, so let's take some value over here. So if I write 1 colon 4, so this is going to represent the value from starting from 1 and end into 3, n minus 1. Okay, so 1 is at 20, 35 and 67. Great. So now let's take, let's remove this n, 1. So when you write in a bracket only colon n, so what will happen? It is going to take the value from 0 to n minus 1. Okay, so now let's run this. So this is going to take from 0, that is 0, 1, 2 and 3. Okay, suppose somebody have write like this 4 and nothing on this side. Okay, so when you write n or a and nothing on this side, so this is going to take the value from a to last value till all last value will be covered. So it is going to start from 4 and all last value will be covered. Great. So 4 is at 89 and 50. So very crystal clear concept, very crystal clear. Okay. So a to n, only n and only a. Okay. So 1, 2, 3 is 1 and 2 only will going to come. Now, how to go for an indexing of 2D array? This was a 1D array indexing. Now 2D array indexing. So now 2D array is created. So let me write down and highlight something on that first. So first bracket, this bracket I'm taking it here, Control C, Control V, and that will be suppose at 0 location. Now the second bracket, this is the second bracket. Now this second bracket is basically at 1 location. Great. So we have the 0 location, we have the 1 location. And inside that hash, the 10 is at 0 location, comma, the 20 is at 1 location, comma, 30 is at 2 location. Okay. So, okay, this is for the first one. Similarly, for the second one also, 40 will be at 0 location, 50 will be at 1 location, and 60 will be at second location. So let's run this. This 2D array is created. So when you write 0, 1, it is first will go to inside this, and 1 means this 2. Okay. So we reach 20. Suppose somebody write 1 and inside that 0. So it will first going to go in this bracket and 0 will be the 40 location. Okay, I hope this concept of indexing for 2D is crystal clear to you. So let's go to the next one, negative indexing. So how the negative indexing works for this? Negative indexing. Okay, so this is considered to be at -1. Okay, and this is considered to be at -2. Similarly, inside that, this will be at -1. This will be at -2 and this will be at -3. So when you write -1, so the first one will be selected, and inside that if you write -2, so 40 will be selected. Okay, great. 50, okay, -2, okay. So -1, -2, 50 will be selected. 40 is at -3. You can mix positive and negative indexing also. Okay, so let's write down here -1 and we can take as 1 suppose. So -1 means this will be selected and inside that 1 will be 50. 50 will be selected. Okay, great. So this is basically the indexing of 2D array. Now let's go for an indexing of 3D array. So now this look difficult, but I'll make it easy for you. So this is a main bracket. Control C, Control V. Okay. So this is the main bracket. Will give a 0, or in the negative indexing, it is going to become as -2. Okay. So now the next one. Suppose we take this one. This is the main bracket. Control C, Control V, and we have the indexing for this is 1 or -1. Both are okay. Now when you go inside that, okay, so now this will be the first one. That will be either indexed as 0 or -2. Great. And the second bracket is considered to be as the next indexing, and that is 1 or -1. Now inside that, if you go, so 11 is considered to be as 0th location. Then 22 is considered to be as 1 location. Then 33 is considered to be as 2 location. Or we can say this is considered to be as, or this is considered to be as -1 location, or this is considered to be as -2 location, or this is considered to be as -3 location. Okay. So we have -1, -2, and -3 location also. Negative indexing is also possible. Similarly, I have written for this bracket. You can go for this bracket also, writing this same way, and each element also you can write it down. So the 3D array is created. Now let's try to understand how the indexing goes. Suppose 0. 0 means the first one will be selected. Inside that 1. 1 means the first one will be, this one will be selected. And inside that 1 means 55 will be selected. Okay. So if I write it here -1, so -1 means this one will be selected. Inside that 1 means this one will be selected. Inside that 1 is 85 will be selected. Okay, very crystal clear concept. Okay, you can mix two things also. Like this is -1, so this will be selected. After that, -2 means this will be selected. And inside that 1 means 28 will be selected. Okay. So the concepts are very crystal clear. You can go and iterate through all the elements of 1D, 2D, and 3D array using for loop also. So 1D array is created. Now I'm taking a value from X. So X is basically my array, and I'm just iterating to all the values of X, and I'm printing that. Yes, it's possible. Similarly, I can do it for 2D array, and similarly I can do it for 3D array also. Okay, so each element iteration is also possible. You can see I'm iterating through each value. Similarly, 2D also I'm iterating through each value, and 3D also I'm iterating through each value. Okay, so suppose we have the array like this, and I want to take it from 5 onwards. This is basically called as a slicing of the array. Okay, this is basically called as a slicing of the array. You can see from 5 all values will come. It's same as the indexing concept. Okay. So now let's go to the next one. Let's go to the next one, and that will be 1 minute. Great. So the next one will say okay. So what next one we're going to say? Okay. So this is the array which I have created, and I'm not going to take up to 2. So 2 will not be included. It is same as the indexing. So we named it as slicing. Negative slicing. So from -3 to -1. So -3 will be from here. Okay. So -3 to -1. That means 56 and 86 will going to come over here. Minus 3, you might be wondering, sir, why minus 1 is not been considered? Because it is always n plus 1 when you take a negative indexing. So n minus 1. So minus 1 minus 1, that will be minus 2. So this is going to take the value from minus 3 to minus 2, n minus 1. Okay, great. Similarly, we can take the value like this. So this is going to take the value from 1 to 5, but skip one value. So it is going to skip one value, and it is going to print the value from 1 to 5. So 1 means 24, 36 will be skipped, 42, 5 will be skipped. Okay. So now let's go to the next one. This is basically going to show you the index of particular part, particular specific location. So let me write down this first easy way. Suppose we take a 0 location. So in the 0 location, what will be the value? 10. Now if I write suppose 0 and 3. So in the third location, what is the value? 0, 1, 2, 3. 40 will also come. So 10 and 40 will come. Okay. Suppose somebody has written minus 2. So what is the array? The minus 2, minus 1, minus 2. 80 will also going to come in the array. Okay. So now this is very clear. So you can go to the specific element 2. So this will going to come as 30 also in the array. So 0th location 10. Third location 40. Minus 2 location 80. And 2 location that will be 30. Great. So now suppose you want to go like a specific location for a 1D array. Similarly, you can go for a 2D array. So this is going to take 0 and 0. So 0 is of this value and 0 means 10. This is going to take 1. So 1 means this will be. Okay, and inside that 1 means this. 2 means this bracket will be selected. And inside that 1 means 60 will be selected. So you have to take a combination of that. So 0 and 0, 1 and 1, and 2 and 2. This way combination is presenting over here. You can just take all the values which is greater than 50 also. Suppose you have the value like this and you can just choose all the value greater than 50. You can choose all the value which is divided by 30, and just after choosing that value, I'm going to square that. Okay. If you get confused, just let me remove this first. Okay. So I'm going to choose all the value which is divided by 30. Okay. 30, 60 and 90. And now I'm going to square that. So this is a squaring of each of the value. 30 will be squared, 60 will be squared, and 90 will be squared. Okay. Now this is slightly heavy. Okay. But we'll try to understand. What is the meaning of this? So first, the addition of each of them will be chosen. So addition of this is 30. The addition of this is 70. The addition of this is 110. Okay. So which bracket is actually divided by 30? The first bracket. So that will be shown over here. Suppose if I make it here 30, then this bracket will also going to become. Okay. And if I make it 60 over here, because the addition of this will be the value which is divided by 30. Great. Now suppose you want to go to the second value of each in 3D array. That is also possible, like 30, 60, 90, 120. So you could just write all 3 dots, comma 2. So this is going to be on the second element of each of them. Okay, great. Suppose you want to reach to the specific element, that is also possible. I already covered that in previous part. Suppose you want to check the dimension of that. Suppose you have taken this and you want to check what is the dimension of that. That is also possible. So the first is 0 dimension. Second one, we can observe this 1D array, 2D array, and 3D array. Let's see how it actually look like. 0, 1, 2, 3 array. You can create an n-dimensional array also. So like I'm creating a 7-dimensional array, you can see 7 brackets are coming up. Okay, so up to three dimension our work will be solved. Suppose I have taken a value like this and I want to replace from 1 to 7, that is 1 to 6, all value to 100. That is also possible. Let's check how it actually look like ARR. Just print ARR. So the new one will be all the values from 1 to 7, 6 will be replaced by 100. Now in NumPy we have a very special method, that is we can just write down the missing value also. So the missing value is represented as .nan. So whenever you see anywhere like np.nan, that means this value is missing value. This value is not available. Okay, so we can just have the printing of that. Okay, we can find out how many elements, okay, are there. So there are three elements. Okay, as per the index. So we are checking index 0, 1, 2, 3. So in NP array, in NumPy, the array is basically called as a NumPy ND array. Great. You can check out the type, the data which you have stored inside that. You can check out the data type also. So this is going to show you a integer exactly, but this is a weird answer will going to come, and that is U9. Okay. Suppose you want to store everything in integer itself, so you can just write down I over here. This is going to store everything in integer. Even if you go give you the value as float, okay, the value will be converted into integer and stored into integer itself. You can take a particular element and perform addition or subtraction operation as per your requirement. Okay, you can just split your array. You can just split your array as per your requirement. Okay, so I'm splitting this array in 4 parts so that I can work along it with it. So I'm making it in a 4 parts. The first part will be this one, the second part will be this one, third part and fourth part. So I can make it in a 3 parts also. So I can create my array in a small parts also. Great. Okay, so let's go to the next one, and in that I'm just going to check where are the ones inside the elements. You can see it is very difficult to find out the location of a particular element in a list, but it is very easy to do that in array. You can check out the one is at one location, two location, and the sixth location. Next, you have suppose an array like this. You can just sort out that. Great. Okay. So now this is a very special part. Okay. Suppose wherever there is a true value, that will be represented like 10 and true. So 10 will be represented, but 20 and false, so 20 will not represent it. 30 and true, the 30 will be represented. Okay. Now the next part is suppose a equal to np dot array, and I just want to check out how many repetition values are there, and I want to just remove that. That is also possible. So all the unique value will be represented, repeated will be removed. I can just check out what is there in the first axis. You can see, and that I'm sorting it out in ascending order. So this is ascending order. I can have the last axis also in the ascending order. You can see this is also basically changed into the ascending or sorting place. Sorting has been taken. You can do a sorting in any axis also like this. See here. So axis will be removed and sorting will be done. Okay. Suppose you have 2D array, 1D array, any D array, and you just want to check how many non-zeros values are there. You can see there are 4 non-zeros value. So everything which is very important to the NumPy array operation, indexing, how to create it, some operations, addition operations I covered in this tutorial. I hope this is useful to you. In this tutorial, we'll try to understand the next part of the NumPy. NumPy is a numerical library of a Python, and it operates on various kind of a data, a normal data and array data also. Okay, so let's try to understand what is there in next learning of the NumPy. Great. So first we need to import NumPy's NP. Okay, NumPy's NP. So this is very much required to call the library. Okay, so we are basically calling the library and we are basically importing as NP. So whenever you write NP, that means we are using a NumPy library. Now the next part is we are creating the A range operation, okay, from 0 to 10. So when you run that, it is going to give the value from 0 to 9. Okay, so whenever you write A range operation, in the bracket, suppose A to N. So that will be going to create the value from A to N minus 1 always. Great. So suppose you have taken 0 to 10, that is going to create the value from 0 to 9. You can create the value like this, A to N and bracket 2. That means it is going to create the value from 0 to 10, but it is going to skip one value because we have written 2. So it is starting from 0, one value is skip, 2, one value is skip, 4, one value is skip. You can create all zeros value like this, 3. So 3 zeros will be created. You can create all one value. Okay. So don't get confused with 0 dot. This is integer itself. 1 dot is integer itself, 1 only. Okay. You can create a scale using line space. Linspace, just mark out the word linspace. Okay, now what is the meaning of that? So it is going to take the value from 0 to 10 and divide into 4 parts. So let me write down what is the meaning of linspace. So in linspace, A comma N comma suppose B. So it is going to create the value from A to N, not N minus 1, and divide into B sets. Like you can see, B 4 part it is divided. So starting from 0 and it end on 10 and divided the total 0 to 10 into 4 parts. So this is also going to create from 0 to 10 and divided into 50 parts. So you might be wondering, it should come 0.2 over here. So you have to take 51 for that, because the 0 and 50, 10 is also been considered, so you have to write 51 over here. You can take the value from 0 to 1 and divide into 20 parts. Okay, and if you want a proper answer, then you just need to include one more over here. Okay, you can create an identity matrix or identity array using EYEI. So now let's see how the random operation works. So when you write random.rand, 2 random values will be generated. When you write random.rand 5, 5, okay, there will be 5 brackets, and inside that 5 random values will be created. You can choose one random integer value, 1 to 100. Every time you run, you will get the different random values between 1 to n minus 1. You can take 1 to n minus 1, and the 10 value will be choose from that. So every time 10 random values will be created. You can create an A range operation, and you can just you can create an A range operation like A range n. So this will be going to create the value from 0 to n minus 1. Okay, and so this will be created 0 to 8, and I'm going to reshape to 3, 3 because the values are 9. Okay, 0 to 8 values are 9. It is going to reshape it to, okay. Now this is also one special part. This is going to create the value from 1 to 100, and it will be going to reshape to 10 into 10. And each value inside that will be divided by 100. Okay, so from 1 will be divided by 100, 2 will be divided by 100, and so on. So 10 by 10 matrix or array will be created, and each element is divided by 100. Great. So now I'm creating again 0 to 24 a range operation. I'm just checking the shape of that. That will going to become 25 comma nothing because we are not given any axis. We can just find out what is the max value inside that, what is the mean value inside that. I can reshape it to 1 comma 25. This is a 2D array. I'm creating 1D to 2D. Okay. I can create this way also 25 comma 1, 25 brackets. Inside each bracket there will be one value. Okay. I can reshape it as per my requirement. I can create the sequence in negative side also. Like I'm creating a sequence. Let's take it as first -1 so you will understand. So it starts from 10, 9, 8 and so on up to n minus 1, n plus 1 it is going to go. And when you write here -2, it is actually skipping one value. Again I'm creating the a range operation 0 to 9. And now I'm taking -7 to 5. So -7 is this. -1, -2, -3, -4, -5, -6, -7. So it will start from 3 and 5. 5 is n minus 1 is 4. So 0, 1, 2, 3, 4. So it is going to show me the value from -7 to 5. So -7 is 3 and and 4 is 4. Okay. We can slice like this also. 3 to 6. Start from 3 and 6 means n minus 1. I am creating a range operation. I can reshape to 5 comma 8 or 8 comma 5. The multiplication should be 40. I can reshape it to 4 comma 10 also. 5 comma 4 also. Okay. So now I'm creating a random integer 0 to 50 and 20 values will be created. I can check out the max value from that, mean value from that. Okay. Every time max and mean value will going to come different because we are creating a random integer number. I can just find out where the maximum number is located. On the 14th location, the maximum number is located. Okay, you can just count it out 0, 1, 2, and so on. You can find out the minimum value location also from the end. So it is on 0th location. Minimum value 8. Okay. So let's check for the next one. Okay. So I'm creating again random integer of 10. And that is also possible. Just write down size 10. I am creating a random integer between 100 to 299 and the size is 10. So 10 random values will be created. Every time you run, you will going to get a random values. The random values can be used for encryption purpose or for some other purposes also. Okay. So the next part, I'm creating a random integer 3, 4, 4. So 3 main brackets will be created. Inside that 4 mini brackets will be created and each will be having 4 elements. So you can see there are 3 main brackets. Inside that 4 small brackets 1, 2, 3 and 4 and inside each of that there are 4 elements. Let's create one more 3 by 3 random arrangement. Now I'm going to sort it out. So when you sort it out, it's sort out basically bracket by bracket. So this has been sorting ascending to ascending values. Okay. You can see sorting out has been taken place. You can just find out the minimum value of that. Okay. And you can just find out the normalized value of each of them also. Great. Now I'm creating a random 7, 4. So 7 brackets and each will be created 4 elements. Now I can skip the rows like this. Suppose I want the first 3 row only and all columns. So first 3 row will be selected 0, 1, 2. You can see 0, 1, 2. Next, all rows will be selected. First 3 column will be selected. Okay. I can have the value from 0 to 15 or 0 to 14 and I can shuffle it. Shuffle means random way it is going to come every time. You can do shuffling operation using permutation operation also. So every time you run, you get a different shuffling. Now I'm creating a value from 0 to 100, and the 50 value will be selected, and I'm just going to count out which one is repeated mostly. So you can see the 8 is repeated mostly inside that. You can run one more time. Every time you get a different answer because it is a random way it is going to create. Okay, I have suppose a value like this, and I just want to count out how many times which one has occurred. Okay, so let's see. So 0 is basically on the 0th location. Okay, 1 is basically occurred 3 times. 0 is occurred 1 time. 1 is occurred 3 times. 6 has occurred twice. 1 has occurred once. 1 has occurred. Okay, so 1 will also be considered over here. Na? That's why. Okay, so you can check out this way the number of occurrence of each of the array. Okay, because the 1 is also already been considered over here, so it is showing over 0. Great. I hope this is very much clear to you.
The next part of NumPy, and this is basically all the mathematical advanced and basic mathematical operation which are possible with NumPy that I'm going to cover in this tutorial. So let's try to understand, figure out how the NumPy works for mathematical operation. So it's this numerical library, so it is going to do a lot of numerical operation possible with NumPy. So let's try to understand how it actually works. First, I'm importing NumPy as NP because I'm going to use NumPy again and again. So instead of writing NumPy, I'm going to write NP inside that. Okay. So the first operation which I'm starting is very simple, the addition of two number, and then the subtraction of two number, the multiplication of two number. Okay, you can just write down multiply, np dot multiply, np dot divide. Very simple operations. Okay, these are the simple four operation, arithmetic operation are possible. So now let's go to the next one. Suppose you have the a range operation 0 to 9. You can just check out the true division of that. True division means each value will be divided by 2 and the value will be presented over here. 1 divided by 2 is 1 0.5, 2 divided by 2 is 1, 3 divided by 2 is 1.5. You can have a floor division also. So I understand in a simple format. What is the meaning of floor division? Floor division actually check your quotient. Okay. So it is going to give you the quotient. Like 2 divided by 2 is 1. 3 divided by 2 is 1. Quotient. You can find out the quotient of that. Okay. So now let's see if I take a power of each. So the element from 0 to 9, each value will be power 2 this way. Okay. The next one is finding the remainder also possible. So like true division give you a true divide, the floor division will give you quotient, and if you write a remainder, it is going to give you each value divided by 2 and the remainder will be presented over here. Okay, now suppose if I take a 3 value minus 10, 12 and 0.3. This is the original array. I can find out the absolute value of that. Okay. Suppose I have the value 1.75, 1.55 and 2.55. I just want to round that. So that will be 2, 2 and 3 will going to come. Suppose I have a 0.38, 0.75, 0.54. I want to round off to decimal 1. Okay, after rounding off only one decimal will going to come. Okay, suppose I have array like this minus 1, 0 and 1. I can find out the sign hyperbolic of that. I can find out the inverse sign of that also. So these values I'm finding the inverse sign of that. I can find out the same value cosine values of that cosine hyperbolic. I can find out the inverse sign cosine of that. I can find out the tan value of minus 1, 0 and 1. I can find out the inverse of that. Okay, tan operation, inverse tan operation. Suppose I have value 180, 90, 90 and 180. This is the values in degree. I can convert that into radian. So these are the radian value. This is pi, pi by 2, pi by 2, pi. So this is minus pi by 2, minus pi by 2, pi and pi by 2 and pi. I have other method also. Instead of radians, I can write degree to radian also. That is also going to convert the value into this format. Okay. Suppose I have np.py. So what is the meaning of np.py? It is minus pi by 2, plus pi by 2, and plus pi. I can convert that into the degree. I can have a radian to degree transfer also. Great. Suppose I have sine value. Okay. And I want to find out the sine of 0, 30, 45, 60, 90. Okay, you have to write np.pi divided by 180 to convert this value into degree. Otherwise, the answer will come wrong. Okay, so this is value which are created in term of sine 0, sine 30, sine 45, sine 60, sine 90. You can find out the cosine value also. So 0 cosine value, 1 cosine value, you can find it out. You can find out the tan of 0, tan of 30, tan of 45. This is a trigonometric operation. Suppose you have a random value from 0 to 10, and I can find out the mean of that also using x mean operation. I can find out the standard deviation of that. I can find out the variation of that. Okay, great. So you can see so many operations has becomes very easy using NumPy. Suppose you have a matrix like this. This is not array. This is a matrix. Okay, you can see there's nothing written. Brackets are given. So 2 into 2 array. Sorry, 2 into 2 matrix. You can just multiply 2 matrix like this. Multiplication. Suppose I have an array like this 1, 13, 15 and 17. I just want to find out the difference between both of them. So 1 and 13, what is the difference? 12. What is the difference between 15 and 13? That is 2, and so on. So you can find out the difference is 12, the difference is 2, the difference is 2, the difference is minus 17. You can create the array like this 1, e raised to 1, e raised to 2. So it's 1, e raised to 1 is 2.71, e raised to 2 is 7.38. I can find out the natural log of that. Okay, 0, 1, 2 is come. I can find out the common log, that is log to the base 10. And even I can find out the log to the base 2. See, the things have become so easy using NumPy library. Okay, so now I have suppose array like this, and I can do a element wise arithmetic operation also. So I can add that, I can subtract that. Each element is been added, each element has been subtracted, each element has been multiplied, each element has been divided by each element. Okay, and I can find out the square root of that each element also. Okay, great. So now suppose I have two numbers. I'm going to take these two numbers from user itself, and I'm going to find out the LCM of that. So suppose if I take a 4, press enter, then 5, press enter. Okay, the 20 is the LCM of that. You can round off the value which is given by the user. Suppose your bill is 45.67. You can just round off to 2 digits. Just press enter. Your answer will going to come. Okay, so I have taken 2 digit itself. So you can take 45.674 like this. Press enter. It's going to round off this way. Great. So now suppose I have the value and I can just convert into the flooring and sale value. See, let me write it down, then you will understand. Suppose 35.7. So what is the highest value in the 35.7? It is 36, and lowest value is 35 in that range. So when you take a floor, it will be 35 and the sale will be 36. And you wonder to see one more thing. Suppose if I take a 35.2, still the floor value will be 35 and the seal value will be 36. So it's not rounding off operation. The floor and seal will be the upper value and the lower value of that fractional value. Suppose you have two lists like this. I can convert this list into array, and each element can be multiplied. So it is very difficult to do that in list, but it is very easy to do that in array. So I convert this two list into array, and you can see I can multiply each element in the list very easily. So let's see a lot of next mathematical operation which are possible with NumPy. Suppose I have the value like this and I just want to find out the remainder. So each value will be divided by 2 and the remainder of that will be found. Okay, the first remainder, second remainder and so on. I can copy the sign of one value to other value. Okay, so -1 sign will be copied to this. I can check whether it is a sign bit or not. If it is negative, it is going to say true, and positive, it is going to say false. I can check whether the number is infinity or not, or sorry, finite or not. Yes, it is finite number. Okay, I can just check out the LCM of that, was just writing LCM. I can just check out the GCD, that is common divisor of two values. I can find out the reciprocal of any value. I can find out the even reciprocal of an array. We can find out the cube root using NumPy very easily. We can find out the square of each of the value in the array using NumPy. I can find out the square of each of the element. I can find out the square root of each of the element. You can see the program which has already been written inside the NumPy. We are using that. I can find out the log to the base 10, log to the base 2 of the elements, normal log, natural log of that. Okay, I can find the e raised to value, e raised to 2 and e raised to 3. I can find out the complex conjugate of that. I can find out the negative value of each of them. Okay, so one negative is minus one negative will be 1. I can just find out the sign of that. So this will be negative sign, this will be positive sign. You can see -1 and 1. I can find out the absolute value of a complex value. Now this is a very special operation. I can find out the quotient and remainder at the same time. So you can see 0 to 5. 0 to 5 value is taken and each value is divided by 3. So these are the quotient and these are the remainders. Great. I can create the value from 0 to 5 and find out the power of each. Okay. So 0 to 5 I'm creating and each value have the power of 3. So again, now I'm creating the 1 to 26. That means 1 to 25 reshape to 5 comma 5. So array of 5 comma 5 reshape is created. And now I'm going to take from 2 onwards everything and 1 onwards everything. So 2 onwards will be this part. Okay. And 1 onwards means this part. So this row and column will be selected, not 16 and this part. Okay, you can check out this. So particular element also I can reach the third and fourth. So 3 will be this and 4 will be this. So 20 will be selected. 3 will be this and 4 will be this. 0, 1, 2, 3. And 4 will be 0, 1, 2, 3, 4. Okay, great. I can take up to 3 and column from 1 to 1. Okay. So for 4, all elements 4, that means the row number 4 will be selected and all columns will be selected. The row number 3 and 4 will be selected and all the columns will be selected. Great. I can find out the sum of each of them, sum of all elements. I can find out the standard deviation of each of elements. I can find out the sum of all the rows. Sum of all the rows. I can find out the sum of all the columns also. Great. So now let's see more arithmetic operations which are possible with NumPy. So I'm creating the value from 0 to 9 array. And I'm adding the same array to the same array just to show you the addition operation. Okay. So each element will be added to each of them. You can multiply, you can divide. So 0 divided by 0 is going to say none. That value is missing. So 0 divided by 0 is not possible. So it is saying NaN, value is missing. Okay. So all elements minus all elements, that will be negative itself. Great. So all the mathematical operations which are possible with NumPy is been covered in this tutorial.
This is NumPy tutorial number 4 and we will try to understand a lot of new things in this tutorial. So this tutorial is dedicated to the string operation using NumPy. So it is said this way, if your language, programming language can work on the string very well, that programming language is the best programming language. And NumPy basically can do a lot of operation with string. See, most of the search over the internet is basically the string itself. So the programming language which you are using must operate well on string. Otherwise, there will be a trouble. So let's try to understand how the NumPy works on string. So NumPy, import NumPy as NP. I'm creating an array name as Intel and Microsoft. Okay, the data type is a string. So X1 is created. Similarly, Google and IBM, X2 is created. 4 big company names. Now I'm going to add this both of them. So it will going to come in single array. Okay, see, you can see. Okay, now I'm creating an array Intel, Microsoft, Google, and IBM. The data type is a string. I'm just capitalizing each of them. So the first value will be capitalized and the other value will be small. I can just convert into the lower case also. NPCHAR, lowercase. I can convert this into the uppercase also. I can do a case swapping. So small will be capital, capital will be small. I can do a just title casing. Title casing means the first will be coming to be as capital, first character. Great. So now I'm creating again the same array, Intel, Microsoft, Google, and IBM. I can just kind of count out how many small I are there inside that. So small I is only Microsoft small I. Okay. So that one will going to come over here, otherwise 0 will come. I can just count out how many capital I are there. So in Intel there is a capital I, in IBM there is a capital I. So other place it is going to say -1 and 0 means that is available over there. So two way of finding out. Either you can just write down count or you can write down found. So when you write count, it's going to say in terms of 0 and 1. Okay, 1 means present and 0 means not present. And when you write find, it is going to say -1 and 0. -1 means not present and 0 means present. I can check out whether it is starting with capital I. Yes, so first true, both second are false. Great. Okay. I can just do a central filling like this. See how many characters are there. So let me take this here itself first to show you something. So before we go for the next one, let me take it here. Okay. So let me run this. So how many characters are there inside that? 5. And we are going to fill up with 15. So the 5 will come on this side, 5 will come on this side. Okay. So when you run this, you can see the 5 spaces coming on this side, 5 on this side, and 5 over here. So Microsoft have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So 3 will come on this side, 3 will come on this side. Similarly, Google 6. So 4 will come on this side. 6. So 5 will come on this side and 4 will come on this side. IBM 3. So 6 will come on this side and 6 will come on this side. Okay, you can just central that. Okay, by giving the space. Instead of this line, you can just give a space also. So you can centralize it properly. Great. You can do a left kind of a assignment also. You can do a right kind of addition of that also. So everything will come on a same line. Okay, you can just add that part into the normal character. In between the character also you can add it. So we can just replace IBM with Motorola in the string by the replace operation. Again, I'm creating an array. So there are two arrays are created, X1 and X2. You can see capital IBM, Microsoft, and MHM. Okay, here also I'm creating an array. I'm just checking both are equal or not. So wherever there is a equal, the true will come, and if not equal, the false will come. You can check Microsoft equal, Intel equal, MHM equal. So there will be true will come, and other place false will come. So now this is a reverse operation, not equal. So wherever there is a false, there is a true will going to come. I can just split out the MHM outcome based education. Okay, so MHM outcome based education will be split with the space. Whenever there is a space, that will be split. Suppose you have a comma, you want to split with the comma, that is also possible. So suppose MHM comma outcome comma base comma education, then the if there is a comma, it will be get separated. You can join the MHM with underscore like this. Okay, you can join with the line and the colon like this. Great. Suppose I just want to count out how many time of MHM is there inside that. So there's a 1 over here, there's nothing over here. I can just count out the substring also. Wherever there's a out, the 1 will going to come. Okay, there's no out. Yeah, you see, there's a out, no out, no out. Okay, I can just find out MHM substring. That is also possible. So first there is a MHM, so 0 will come. Other place there is no MHM, so -1 will going to come. I can just find out using rfind also. So out is available over there, so 0 is coming, and -1, that means that out is not available over there. I can check out whether it is a numerical or not. Yes, it is numerical. The MHM is numerical. The answer is no. I can just check out whether both are equal. The answer is for sure false. Now I can check out whether both are equal. That is true. So the programming language which can work on a string very nicely is the best programming language, and NumPy as a library can work on lot of operation on string. So suppose you have a message like this, two kind of a message called ham and spam. Spam means useless messages, okay, promotion messages, marketing messages, and ham means useful messages. So you can just split your message into small parts and check out whether it is a ham or spam using NumPy library. In this tutorial, we will try to understand the linear algebra and statistic operation which are possible with NumPy. Okay, so first we will import NumPy as NP because we are going to use NumPy. Okay, and now I am creating an array and I'm going to use a very special function called as a lineage. Okay, this function is basically to find out the determinant of the array. Okay, so this is an original 2D array and I can just find out the determinant of that using very easy method, that is the lineage dot determinant. Okay, I can do a statistic operations using NumPy. So a equal to, I am creating a 2D array of shape 2 comma 2. I can just find out the max value from that, mean value from that. Okay, suppose I'm creating a value from 2 comma 5 and I'm just finding out the percentage 70 percentile of that. So this is create 0 to 9 value and will be placed over 2 comma 5. So this value and this value. Okay, so what is the 70 percentile of that? 2.8. What is the 70 percentile of this? 7.8. Okay, you can just check out with some other method also like 5 comma 2. So that is also going to give you the 5 different value. 1 and 7, 70 percentile is 7. 2 and 3, 17 percentile is 2.7 and so on. Great. Now suppose I have a value from 10 to comma 5. I just want to find out the median of that. Okay, so median of this is 4.5. I can find out the covariation or covariance of two array. Great. I can find out the mean of values. Suppose we have the values like this, number like this, and I just want to find out the mean of that. Okay, that is possible. I can find out the mean of that and just round it off. and just print the rounding operation of that. Yes, 88.8 is 89. I can find out the median of that also and print the median. I can find out the variance of that number also, and yes, printed variance. So these are the statistics data which are required for some of the time for a statistical operation. Okay, so we have a NumPy to help us to find out that. You can find out the standard deviation of that number. Okay, so you can just find out the square root of the standard deviation. That's sometimes it's required also. Now the percentile, like suppose we have number here which we have presented over here. Okay, I want to find out the 85 percentile of that. Okay, so you can see 85 percentile of all the values is 100.5. Great. Suppose I have a matrix like this, and the rank of that matrix I can find out using lineage function. I can just directly find out the invert operation also, inverse of this matrix. Great. Suppose I'm creating a matrix again, and suppose I want to find out the eigenvalue of that. I can do that using eigenvalue. Okay. LG is not defined, so we have to write here as LG. Okay, we have to run this first, and then the eigenvalue will be created. And I can just find out the diagonal elements. I can create a diagonal element matrix using that. So 2, 5, and 8 will be come into the diagonal elements. So very simple and straightforward operations. I hope you know what is the meaning of variance. If you don't know, you can just read out what is the meaning of variance, standard deviation I have written over here. So it is expected that you must know that what is the meaning of percentile. If you don't know, it's completely fine. You can just read out the comment and understand what is the meaning of that. In this video, we are trying to understand how the date and time function can be worked with NumPy. So NumPy is a numerical library and it can able to work with date and time also. So let's try to understand how it actually works. So import NumPy as NP. Okay. So if you get such message in Google Colab, just terminate some of the connections. Okay. Import NumPy as NP. And I'm just checking today's date using NumPy. Okay. Today's date is 18/10/2020. I can check out the delta 64. Okay, D164. Let's try to understand what is the meaning of that. The second one is 2D or 1D, and this function we are going to use in the next one. Okay, so this is D1, this is the 2Ds. Okay, suppose you want to check the yesterday, so it will be 2D minus 1D. This 1D. Okay, you want to check day before yesterday, that will be 2D minus 2D. 2D function what we have written over here. Okay. You want to check for the tomorrow, 2D plus 1D. Day after tomorrow, 2D plus 2D. Okay. You want to go to the particular year and check out all the dates of that. That is also possible. July, full July month we are checking. You can just count out how many days are there in the February 2020. That is 29 days because it's a leap year. You can just find out the start and end time. Okay, so you can see the 2020 day number 6. Okay, that is June is a month and day is a 3. And I'm just checking the hours, 0 hours, 1 hour, 2 hour, and up to 24, 23 hours. So 0 to 23 is 24 hours. Okay, I can just check out how many Sundays are there. Okay, the first Sunday of 2020. Okay, first Sunday of 2020. I can just find out the weekdays in February 2020. So there are 20 weekdays. So these are the operations which are useful for date and time function with. In this tutorial, we will try to understand the logical operation possible with NumPy. So import NumPy as NP first, and we are going to do a logical AND operation, XOR operation, AND operation, or XOR and AND operation. So first, what is the OR value of true and false? For sure, it is true. Suppose I have an array like this, I can check out this way. True, false, it is going to come to as true. So in OR operation, if single value is true, the output will be true. So this bracket and this bracket will be OR, and the answer will be represented. Now the AND operation, this two value will be AND. Any one is false, the answer is false. So now this bracket and this bracket will be AND or AND and element wise, and the answer will be represented true, false, 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 false. Similarly, XOR operation, true, false, it is true. Okay. Now there are three numbers and three numbers over here. Okay, true, true, the answer is true, sorry, false. Because in XOR, if the both value are same, that is true, true, answer is false. False, false, answer is false. Okay. Now suppose if I'm creating a value from 0 to 5, that means 0 to 4 will be created. Okay, and I'm just checking which number this number is greater than 1. If number is greater than 1, that is true, and number is less than 4, that is true. If both are true, the answer will be and the answer will be true. So from 0 to 1, 0 to 4, the 0 is basically greater than 1, no, false. This is true, so true, false, the false. Okay, so the next number is 1. So 1 is greater than 1, no, but less than 4, true. So this is false, this is true. Okay, so answer is coming as basically false. Now the 2 is greater than 4, answer is yes, true. This is also true because the 2 is less than 4. So the answer is 2 is coming. The next one is 3. So 3 is greater than 1, true. 3 is less than 4, true. So answer 2 is coming. Similarly, you can do the logical NOT operation also. Yes, 0 to 4 I am creating. The 1 is less than 3, true. So answer will going to come as false because we are doing a NOT operation. 1 is less than 3, true. But we are checking the NOT operation, so it is coming to be a false. 2 is less than 3, true. So the answer is coming is false. Great. So this way logical operations are also possible with NumPy. Now in this video I'm going to take you to the official website of NumPy, and we will try to understand how to use all function of NumPy from official website. So numpy.org is the official website of NumPy, but there are a lot of information given when you come on this website, and everything is not useful to us. So the simple logic is we actually go to the quick start kind of tutorial, and I'm going to provide you the link for that. So I recommend you to copy the link from here. You can pause the video and you can just take a screen capture of it. So this is a very important link of NumPy official website. Now why it is important? Because when you come here, all basic operations to advanced operation with NumPy has been given with example. You just click any one of this. Suppose I'm clicking on basic, so it will take me here, and I'm coming down, and with the example everything is given. So I will just copy paste this first. Copy, I will go to my Jupyter notebook. I will just paste it and run. So first command is clear. So I'm importing NumPy as NP. Now next you can take directly creating an array from it. Okay, you just copy paste into this and you run it. You can check the value of A. So A matrix has been created. Now all possible operations, advanced operations with examples and explanation it is given. So as and when you want to use any special functions of NumPy, you can directly come to the official website and you can just click, like suppose I want to learn the linear algebra, you come down here, use any example of a linear algebra, just copy paste it and run it. So you need to copy this, paste into your notebook or Python ideally and run it. So this way you can learn all possible functions which are available with NumPy using the official website of NumPy.